Introduction, RoboSwap, a GAN-driven video diffusion framework for unsupervised robot arm swapping. Recent advances in generative models have revolutionized video synthesis and editing, yet the lack of diverse, high-quality datasets limits robotic generalization across platforms. Previous works require the paired video data across to supervise the robot arm translation model, which is impractical. To tackle this, we introduce RoboSwap, a novel method which enables unsupervised robot arm swapping without paired video dataset. RoboSwap introduces a video editing pipeline combining GAN and diffusion models. First, an unpaired GAN transforms one robotic arm into another after foreground segmentation. In the second stage, the transformed robotic arm is fused with the original video background, and a diffusion model is used to optimize the result, enhancing overall video consistency, motion realism, and interaction plausibility with objects. The two models are trained independently, with the GAN's output serving as the diffusion model's input during inference. We conduct both qualitative and quantitative evaluations. For quantitative evaluation, we adopt vBench, while for qualitative evaluation, we perform a user study to assess whether the swap is successful and which methods are preferred. Our experiments demonstrate that RoboSwap outperforms state-of-the-art video and image editing models on 3 benchmarks in terms of both structural coherence and motion consistency, thereby offering a robust solution for generating reliable, cross-embodiment data in robotic learning. In the comparative experiment of image editing, we compare our method with Paint by example and any door, and only our method successfully replaces the robotic arm. In video editing, we compare our method with any V2V, I2V edit, and 2 image-based editing methods. The 2 image-based per-frame editing methods failed to complete the replacement task. Any V2V, a tuning-free approach, successfully interacts with the background but fails to maintain the structural consistency of the robotic arm. I2V edit, which trains a dedicated LoRa model for the source video, fails to interact with the background, preventing the task from being completed as objects are not grasped. Additionally, I2V edit struggles to maintain structural consistency. In contrast, our RoboSwap method successfully replaces the robotic arm while maintaining plausible interactions with objects in the scene. The generated lighting and shadows are also realistic and well integrated. During ablation study, we compare with the cycle GAN and I2V background, and I2V swapped. We find that these variants fail to successfully and stably replace the robotic arm. After merely modifying the text prompt, the output video still retains the original robotic arm structure. Even when both the swapped first frame and changed prompt are given, the I2V swap becomes highly unstable. The result videos gradually exhibits the characteristics of the original robotic arm. In contrast, our method consistently maintains the structural integrity of the robotic arm while successfully accomplishing the original task.